Hello, everyone. Welcome to our second ACT prep session. It's me, Hafsat, again, as usual. And today we are going to pick up from where we left off last time. And before we move on, I want to just once again recheck if you haven't paid your donation or if your parents haven't done the donation registration fee, please ask them to get to that really soon. And in the meantime, while I'm pulling up my slideshow, I'll just remind you guys of the charity that we're doing this for. If you haven't heard of it, it's called Grace Cancer Foundation. And basically, it is a cancer foundation that focuses on getting cancer care to rural parts of India, parts where, like, my dad might have come from, or parts where your grandparents may have lived. And it's a really impactful program. But enough of that. Let's get straight to learning. So last time we left off, we were doing proportions, and uh, one second. Let me modify the screen a little bit so it's easier. Okay, there it is. Okay. Last time we left off, we were doing proportions, and important concept we covered was that when they give you a ratio of, say, one item to another item, you have to do like item over total. So that shouldn't be that hard. So we're just gonna move on ASAP. Okay. Okay. So is some practice to get you guys started, and I'm gonna give you guys around 2 minutes to do this starting now.
I believe we did this last session.
Oh, did we do this? Oh yeah, no, yeah, you're right. Actually, we did do this last session. Thanks for reminding me. Oh yeah. Oh, wrong proportion. Okay, so there were proportion ones, but that was the previous proportion slide. All right. So this question that we went over last time was basically focused on creating something large out of something small and how you can boil it down to finding the total amount of something over the total amount of something else. So let's move on to another question of a similar caliber. I'm going to give you guys 1 minute to solve this question. Admittedly, it's a little bit different than the it's a little bit different than the one we did together, since we're going from big to small, but the core concept should be there. All right, 1 minute is over, so let's come back and check this one out. Apologies if my writing's going to be a little bit slow today because I'm in a new room. Although you probably can't tell since I'm using a background that I reserved in a library, and I can't bring a second monitor with me. But yeah, okay. So we have County X that has two districts, similar to the last question. So 100 miles, square miles in total, and this is the population density. Uh, Sorry? Okay. Just letting you know, if you guys need to say something, only when you raise your hand, you're allowed to say something. I'm sure that was just a mistake. Anyway, let's continue. Okay. So we have District 1, and we have to find the population density of District 2. So let's first frame the mindset and think, okay, what information do we need to find the population density of District 2? Well, we need the total you need the total amount of people in District 2, and we need the square miles
No, it's 60 miles.
of District 2. So moving forward from that, in order to find this, okay, first we need to find the total amount of people in County X and subtract that from the amount of people in District 1. So how many people are in County X? Okay, well, that's going to be 100 square miles times 150 people per mile. So this is County X. And then we subtract that from District 1. So District 1 is going to be 40 square miles and population density of 200. Let me just get my calculating device out. And I mean, honestly, you could just do this in your head, but you know, why not? And let me just write district one. So then 100 times 150 is going to be 15,000. And yeah, and then 40 minus 200, 40 times 200 is going to be 8,000. So then you get, I'm just going to write 15K and then 8K. So 15K minus 8K, which is equal to 7,000. So that's the total amount of people, 7,000. And then square miles. Okay, well, that's pretty simple. There's 100 total square miles and then 40 square miles in District 1. So District 2 has to be 60 square miles. And then you do 7,000 divided by 60, which gives you 116.67. Now we don't have the exact answer, but remember what I said last class where you got to choose the best answer. 117 is basically the same number in this case, so it'll work. Well, it doesn't seem like there's any questions at the moment. Oh, okay. Well, we do have a question. Okay. So, okay, this is another percentage question, and it's definitely a little bit more complicated. Okay, so we have a furniture store, and they buy their furniture from a wholesaler. So these guys, they buy their furniture from another big producer per se. And the store usually sells a table for 75% more than the cost of the table from the wholesaler. So whatever they got from the wholesaler, they sell it for 75% more in the store. Okay, and then during a sale, the store sells the table for 15% more than the cost from the wholesaler. So wholesale price times 1.15 is going to be the store price at a sale. So although it's 1.15, it's still being increased. Overall, the sale price is lower than the original store price. Okay, so during a sale, the sale price of a table is $299. So what is the usual price of the table? Basically, they're saying, okay, if the sale price is equal to 299, then what is the normal price? And that should be pretty easy. Basically, we take this equation that we set up here and we find the wholesale price, and then we use the wholesale price to find the normal store price. So let's do that now. So in this case, I'm just going to represent wholesale price as X, and I'm going to represent store price as Y, and I'm going to represent sale price as Z for like ease of variables and stuff like that. Okay, well, we don't need to have this because we already know what sale price is. So we'll say 299 is equal to X times 1.15. We divide the whole thing by 1.15, and then we get X is equal to 260. So 260 is the wholesale price. And then in order to find the normal price, we have to do 260 times 1.75 from this part over here. And then 260 times 1.75 is going to be $455. So B is going to be the correct answer. So you see what I did there, where even if they give you a whole lot of information, it doesn't have to be that bad. All you have to do is come to sort of conclusions and build these equations, and then you'll come to an understanding naturally. A thing I like to do is, if they're giving me a bunch of information that is, really easy, like for example, sale price of table is 299, I might underline that or highlight that so I can come back to it later and I can reference it easily. Yes, Naga, it seems you have a question.
I have a question. If it says the usual price, was it asking for the wholesale price, or was it asking for like reduce 15% and then you get the usual store price?
Okay, so it was asking for the usual store price, how much money that the store sells it for, not how much the wholesaler sells it for. That is a separate value. If they use like language such as usual, then it's going to be referring to like what is the central topic of the question, which is in this case store prices. The wholesale price was like an intermediate variable. All right then, good question. Yeah, sometimes word problems can be a little bit tricky to interpret. All right, so I'm gonna let you guys try this question out by yourself. I'm gonna give you guys 1.5 minutes to do this starting now. And also, if you're wondering, you ain't gonna be able to find the answers to these online because I made these questions myself. At least these try it yourself questions. All right then, everybody. So 1.5 minutes have passed. Let's come back and check this problem out. So there's a whole lot of percentages being slung around in this question. The first thing you need to understand is that 100% is considered the entire student population. And you can actually multiply percentages in order to find new percentages. For example, they said that we need to find the percentage of the entire student population at Yellow Fields that likes cookies. So the entire student population, that's going to be sixth graders, seventh graders, and eighth graders. So you could think of that as the total you can think of that as the amount of sixth graders, seventh graders, and eighth graders that like cookies combined. So how do we find that information? Well, okay, the graders make up 60% of the school population, so 0.60. And then it says that 90% of them like cookies. So 90% of 60% like cookies. And what does this equal? It equals 0. Oh wait, just 1 second. It equals 0.54. So that means that we know that more than 54% of the population in the school likes cookies. So this is equal to the amount or proportion of, I'll write that out, portion of sixth graders who like cookies. And then you can do the same thing for the other grades where, okay, what about seventh and eighth grade? So seventh and eighth grade are both 20%. And then, okay, 75% of seventh graders like cookies. And then only 25% of eighth graders like cookies. Those are some grouchy eighth graders. And then you do 0.20 times 0.75, which is 0.15. And then down here, that is going to be 0.05. And then therefore, okay, these are the percentages. So this is the sixth grade percentage, that's seventh grade, this is the eighth grade. You just simply add all those percentages up and you'll find the total student population that enjoys cookies, which is going to be 74%. Now, if the percentages are all like a big mess in your head, another thing you can do is pretend that you can make like you can take like a random number, usually like a nice number like 100 or 1000, and say, okay, I'm just going to pretend that the whole student population is 1000 people. And then you can go from there. For example, with the, I'm going to erase this so that I can make room for the another example. Wow, Zoom's eraser is not great. Okay. If we said, okay, the entire student population is 1,000 and sixth graders are 60% of the school, that is like 1,000 times 0.60, and then 90% of them like cookies, then you'll get 540 sixth graders who like cookies. And then you do the same thing for seventh and eighth grade, and then you add those up, and then you do total amount of people who like cookies over the total amount of people in the school, and you can find it that way, in case percentages are not like your favorite thing to deal with. Naga, you have a question?
Yeah, I tried dividing. I thought you have to divide it because it would be like a fraction. So like it would be like 90% of the 60% would like cookies because
Oh, so did you do 0.60 divided by 0.90?
yeah.
Oh, okay, no, that is incorrect because if you divide by something less than one, you actually increase the value. For example, if you do 2 divided by 0.5, that's actually equal to 4. So, you need to like think sort of like common sense. If something is increasing the value, does it make sense when I'm trying to find something of lower value? Yeah, no, typically, if they say like something anything less than 100% and like of like 90%, then that is going to be represented as like 0.90, and in order to find the numerical value you have to multiply it by the percentages because you're going lower, right? You're going from whole to part of the whole population.
Okay, I understood. Thank you.
Yeah, no problem. All right, moving on. I think, okay, yeah, reading graphs. This shouldn't take very long. It's pretty easy. A lot of questions on the ACT, they're gonna give you a graph and there's gonna be a whole bunch of information on the graph and you have to answer questions based off of the graph. It's not that complicated. There's going to be a whole different bunch of graphs. These are just two examples. One is a time graph and the other one is a scatter plot. And let's take a look at the questions, to see how they are. All right, first one. One evening, Maria walks, jogs, and runs for a total of 60 minutes, and the graph above shows her speed during the 60 minutes. So, the way you can read this is, okay, at 10 minutes, this is her speed on the y-axis. It's 6 miles per hour. Wow, she's quite fast. And okay, the question is, which segment of the graph represents the times when Maria's speed is the greatest? Okay, well, where is her speed the greatest? It's going to be up here. And where does that correspond to on the x-axis? Well, it corresponds to around, what does that look like? 20 and 35. Okay, that sounds about right. And then which answers make the most sense? Okay, well, B looks like a good answer because it says a segment from 19 to 34. Okay, it's basically the same thing as 20 to 35. So it's all good. And the other segments, like the other answers like A and C, they don't make sense because their speed changes, their y value changes, and then D is also wrong because, well, the y value is 6, which is not the highest speed. All right, and then what about the other graph? The other graph is a scatter plot where they're used a lot in scientific experiments. I make a lot of scatter plots here at BU during chemistry, and where basically you take data and you put it on a graph, and then you try and see if there's like a pattern in the data. So here it says, okay, the grocery store sells pints of raspberries and then they set the price per pint each week, meaning they change the price every week. And the scatter plot above shows the price and number of pints of raspberries sold for 19 weeks, along with the line of best fit for the data and an equation for that line. Okay, so what does this line mean? Well, let's take a look at the x-axis. Okay, price per pint in dollars. So this is how much they make the raspberries cost. And then this is how many pints they sell. So as you can see, if we go right on the graph, then the value goes lower. So therefore, the more expensive the raspberries are, the less they sell. And clearly, the data represents that because all the dots have like a downward trend, and the line of best fit, which was like generated probably by a computer, also shows that there's a downward trend. And at the bottom, I wrote down 3 questions that you might see on the ACT for analysis. For example, okay, according to the line of best fit, around how many pints will be sold if the price per pint is $4.50? Now, okay, we can't be for sure, but the line of best fit will give us a good approximation. So you can say, okay, if the price is $4.50. Where does that correspond to on the y-axis? It corresponds to around 90. So you're going to sell around 90 pints. out of the 19 weeks, how many sold more pints of raspberries than the line of best fit predicted? Okay, that might sound a little bit weird to read. What it's basically saying is we have this line of best fit. It's predicting how many pints are going to be sold depending on the price. And obviously, some of the data points are above the line and some of the data points are below the line. So if it's above the line, that means that on that week or at that price point, they performed better than they expected. If it's below the line, then it means they performed worse than expected. So if they ask how many for how many of the weeks did they sell more pints of raspberries than they predicted, all you have to do is count the amount of times where the data point is above the line. So how many is that? Let me clear that up a little bit. Okay, it's going to be 1, 2, 3, 4, 5, 6, 7, 8. So it's going to be 8 weeks out of 19. They performed better than they expected. And then lastly, okay, what does the line of best fit and the y-intercept of this graph represent? Okay, this is actually something really important where you need to use common sense. Okay, it says, what does the line of best fit and the y-intercept of the graph represent? Okay, well, the line of best fit is simply the prediction for how much pints they're going to sell depending on the price. But then they ask, what does the y-intercept of the graph represent? So the y-intercept, okay, is when, okay, if we have 0 is equal to 233 minus 32, x, what is x going to be equal to? So simply all we have to do is do negative 233 divided by negative 32, and then we get x is equal to 7.2812. Oh, wait, no. Actually, that's slightly incorrect. My bad. That was the x-intercept. The y-intercept is when x is equal to 0. Okay, so basically the y-intercept is around, somewhere over here, and it's 1.50. The x value is going to be 1.50 at the y-intercept. But this is incorrect actually, because the graph is not a full graph. When they ask you for y-intercept, do not look at what the graph is showing. Only think in terms of algebra, where where y-intercept means x equals 0. And what does x mean? X means price per pint of the raspberries. So basically it's saying, what is the scenario where if the price per pint is $0, aka free? Well, if you solve the equation, it's going to be 233. So you're telling me that if the raspberries are free, we're going to sell 233 pints of raspberries? Okay, well, that doesn't make much sense now, would it? Because if they're free, then you might sell a whole lot more than 233. So that's what the question is asking. When they ask for an interpretation, they ask, what does it mean? And then you're going to have to follow up sometimes with, does this make sense? Okay, it seems we have some questions. Sripal, you have a question?
Yes. So when it's for the first part, when it says according to the line of best fit, how many, like the first question, would we have to do that algebraically and give the exact answer since it's not like a multiple choice question, or is it like, just 90, like you said?
Oh, just 90. Yeah, you can do it. Oh, okay. For a question like that, if they give you numerical data, then you always do it algebraically. I only did that with my eye because it was easier and because I knew what the correct answer was. But yeah, you always should do that algebraically.
Okay, thank you.
No problem. And Naga, you have a question?
Yeah, I wanted to say something. When they sold it, even though it was above the topmost result, it said that you made like 190 for 200, right?
Mhm.
I took a bunch of them and then multiplied to see the profit, and then I saw that I got 380 for 2 times 190, 400 for 5 times 80. So basically, the lower the price, the less profit they were making. So the highest price they got from sampling it, I got 140 times 3, and that's 420. So I think
Okay. Well, I appreciate your mathematical zeal. Keep that up. Unfortunately, we're not focusing on going that deep right now. You're not gonna have to think that deep on the ACT. Typically, you only have to think about the question. But thanks for letting us know that. Anyway, yeah, let's move on. All right, here is a conceptual word problem. Okay, so a conceptual word problem is basically where you don't have to do any mathematical work. You just have to think with your brain. Okay, every month, Jamal adds 2 new books to his library. Which of the following types of functions best models the number of books in Jamal's library as a function of time? Okay, when they say function of time, what they mean is, okay, how does one variable change when time passes? That applies to anything else. When it says like function of temperature, it's like, how does this change when temperature changes, basically. So okay, the 4 options we have here are increasing linear, decreasing linear, increasing exponential, and decreasing exponential. So what does linear mean? Linear means it has a straight line trend where it can either go up or it can go down. You can go neutral. Basically, it just means straight line. Exponential means it increases at a very rapid rate once the x value goes beyond a certain point. So it is not a straight line. So in this case, it says every month Jamal adds 2 new books, and adding, that should be a sign that this is a linear function, because that is what linear functions basically are, right? Where it's basically every time x increases by this amount, y increases, or you add this amount to y, or you subtract this amount from y. So the add is a signal that this is a linear function. So it's got to be either a or b. And if he's adding, that's increasing, right? So it's going to be a. All right then. So yeah, that was pretty simple. Nothing much to do there. We're going to move on. Okay. Here is a little bit systems review. I'm doing this because I'm going to give you guys a small quiz after this. I'm going to give you 1 minute to solid starting now. All right then. 1 minute is up, so let's come back and check this problem out. Okay. So remember what I said about infinite amount of solutions, where in order to have an infinite amount of solutions, you need to have a statement that is always true, such as 0 is equal to 0. So in order to solve the above equation, if in order to have an infinite amount of solutions, what is the value of A? So another thing I said is that a system that is always true is basically a system where the 2 equations are essentially identical equations, where one equation is just another version of the other equation, or it's just the other equation like times 2 or times 3. If you look at trends or patterns, you can kind of see that the bottom equation is basically the top equation multiplied by 2. So if we wanted this to be a always true statement, then we have to make it so that A is also proportionally larger than its corresponding coefficient. So this 2 corresponds to A. We have to do 2 times 2, and therefore A needs to be 4 in order for there to be an infinite amount of solutions. All right, now here is your mini quiz. I'm gonna give you guys 4 minutes to solve this starting now. Also, you guys are allowed to use your calculator since you're gonna be able to use your calculator in ACT anyways. All right, everybody, 4 minutes are up, so let's come back and check out these questions. All right. So the first one, this one's a little bit different because the total that I give you does not represent the total of the amount of viola players and violin players. It says, okay, there's a total of 180 orchestra players, and it says that the ratio of violin to viola players is 5:1, and that there are 25 viola players. So first of all, how many violin players are there? So the number of violin players is going to be equal to 25 viola players, and then the ratio of violin to viola players is 5 to 1. So for every one viola player, there's going to be 5 violins. So one viola, and then 5 violins. So then how many violins is that? That's going to be 125. Okay, so that's the number of violins. And then they ask, how many players in the orchestra play neither the violin nor the viola? So what is the total for violins and violas? That's going to be 125 plus 25, which is 150. If there's 180 total, then 180 minus 150 is going to be 30. So it's probably like 30 cello or bass players in the band. Yeah. So next. Okay, yeah, similar to that furniture question, we have this one, this question that's based on raspberries. Okay, so on Saturday, a store sells raspberries at 33% discount. And then on Sunday, the store sells them at a price that is 25% greater than the price on Saturday. If the raspberries cost $12 on a weekday, what is the Sunday price? Okay, two things you need to do. First, you need to find the Saturday discount price, and then you need to find the Sunday price based on the Saturday price. So what is the Saturday price? Okay, so it's 33% discount, 1/3 discount, 12 times 0.67. 0.67 represents minus 33%. That's going to be $8. Admittedly, it's probably not exactly 8, but it's virtually the same thing. Okay, 8. And then on Sunday, the store sells them at a price that's 25% greater. So this is the Saturday price. And then Sunday price is going to equal 8. It's going to be equal to 8 times 1.25, which is equal to 10. So the correct answer is going to be B. Okay, the next one, okay, at a local aquarium, there are 240 attendees. Okay, and the ratio of adults to kids is 3:5. How many adults are in the aquarium? Okay, so out of a total of 8 people, it's going to be 3 adults out of 8 total people. So then if there's going to be 240 total people, then there's going to be 90 adults. So C is the correct answer. And then, okay, for this last question, it was a simple function problem. You didn't have to do this by hand. Remember I said you could use your calculators. This is an exponential function. So simply all you had to do, it says, okay, the population grows for 5 years. So T is equal to 5. So you simply do 1000 times 2.5 to the power of 5. And you should have got a value something like 97,656, and then it said half of them die. So we divide this by 2, and you should get an answer of 48,828.15. Now, remember, okay, none of the answers here are exact, but we gotta choose the best answer. A is going to be the correct answer. Oh, that's weird. I wonder why it looks like there's a strike through there. Sorry. But yeah, A is going to be the correct answer, even though C is very close. All right. Are there any questions? Okay. Yeah, it seems we have some questions. Saihasini, you have a question?
Oh yeah, how'd you get 90 for like question number 3?
For question number 3. Okay, so it says at a local aquarium, there's 240 total people, and the ratio of adults to kids is 3:5. So another way you can look at that is that out of 8 people, 3 of them are going to be adults. And then if there's 240 total people, then you can simply solve like that, and you should get a value of 90. Divisha, do you have a question?
Yeah. So for like the store problem, I didn't quite understand that. Like, how did you get like 8 times like 1.25?
Oh, okay. So for that question, what happened is first we had the normal price, which was $12 on a weekday, and then we have to find the discounted price on Saturday, right? So the discounted price is going to be $8 because it says it's a 33% discount, right? So we gotta do 12 times 0.67 to represent a 33% discount. And then if you do that multiplication, it's going to give you $8. So it's gonna be $8 on Saturday. And then it says on Sunday, the store sells them at a price that is 25% greater than the price on Saturday. So it's not looking at the weekday price, it's looking at the Saturday price. And it's 25% greater. In order to represent a 25% increase, we did $8 times 1.25. 1.25 represents a 25% increase, and we got a value of 10. All right, then unfortunately, since we don't have much time left, we have to continue moving on. I did hear some people ask me if I can push these questions online. I'll see if I can clear that with the higher ups. Okay, more statistics and data analysis. So another thing that HT likes to do is give you a lot of data questions rather than graph questions. So let's read this. We have a store and they're deciding whether or not to install a new security system. Based on records, the security manager estimates that around 10,000 customers enter the store each week, 24 of whom will attempt to shoplift. Based on the data below, according to the manager's estimates, if the alarm sounds for a customer, what is the probability that the customer do not attempt to shoplift? Okay, wow, there's a whole lot of words that were just going around. Basically, this whole section here represents all the people who are going into the store, and everything on the left and right represents different conditions that happened. So, yeah. So, for example, if you wanted to find the amount of times where a customer attempts to shoplift and an alarm sounds, then you would have to. Okay, let me change my drawing style. You'd have to look at this category, and then you'd have to look at this category. So customer attempts to shoplift and then alarm sounds. Therefore, this is the box where they intersect. So that data is telling us that out of 10,000 customers, there's going to be 21 customers who will attempt to shoplift and have the alarm called on them. So how do we use this data? It says, okay, the question is, if the alarm sounds for a customer, what is the probability that the customer did not attempt to shoplift? Okay, a thing you need to understand is sometimes the question is going to give you conditions, and then you have to find the probability within the condition. What I mean by that is it says, okay, if the alarm sounds for a customer, so if they're saying, if this happens, like assume this happens, and that means we have to look at this box only. If the alarm sounds for a customer, what is the probability? What is the probability within this box that the customer did not attempt to shoplift? So if you look at the bottom, if you look at the bottom and all the way towards the right, you'll see a totals column, which tells you the total amount of something that has happened. So an example of this is if you look at the totals for customers who attempted to shoplift, it's going to give you a total of 24 total people attempted to shoplift out of 10,000. Now they're saying, okay, the total amount of times where the alarm sounded was 56, right? And then they're asking how many times, or what is the probability that the customer didn't shoplift if the alarm sounds? Well, a customer does not attempt to shoplift 35 times when the alarm sounds. So all you have to do is do 35 divided by 56, and that can be simplified down to 5/8, which is equal to 0.625. And therefore D is the correct answer. Are there any questions? Okay, yeah. Avanish, you have a question?
Sorry, I forgot to lower my hand.
No problem. All right then. Yeah. So I know this is a tad bit confusing. Don't worry, you'll get the hang of it soon. Oh, okay. Histograms, then another one of my favorites. So a histogram is kind of like a bar graph. Actually, it's pretty much the same thing as a bar graph. It's just that the bars are directly next to each other, and it's usually representing some kind of range where it's like this bar is 10 to 20, this one is 20 to 30, this one's 30 to 40, etc. You guys probably already know that. Okay, the question says, the histogram shown summarizes the distribution of time worked last week by the 40 employees. Okay, it says in the histogram, first bar represents all workers who worked at least 10 hours but less than 20 hours. They're just explaining how it works. Which of the following could be the median and mean amount of time worked in hours for the 40 employees? Oh, okay, yeah. It can be a little bit scary when they give you something really open-ended like this. You're like, how do I find the median and mean without the actual number values, right? Well, you don't need the actual number values in order to make an assumption. Excuse me. I'll show you what I mean. So what does median mean? It means the value that is split in the middle. So in this case, if there's 40 workers, it means the worker who has like, the 20th worker who is split in the middle, right in the medium value. So how do we know where the median lies? Well, you see, they give us the number of workers who are within a range. So at what range do we reach 20, the number 20, for the amount of workers? Well, this one here is 6, and this one here is 17. Oh, that's a total of 23. So we already just moved forward by 23 bars. I mean, we moved forward by 2 bars, and 23 people make up the first 2 bars. So that means that our 20th value has to lie somewhere within here, the 20 to 30 range. So that means it cannot be D because that median is 32. Now, okay, the next one, a little bit more tricky. What about the mean? 23, 22, or 32? Now, by the way, if you wanted to check from the other side for median, 60 to 70 is going to be, what is that? 2, this is going to be 1, this is going to be 5, and then this is going to be what? 9. So it would have been 17, and you still would have had to broken into the second bar to find the median. But yeah, anyway, back to what we were saying. Okay, what about the mean? Okay, if you have to think about this logically. Okay, what if the mean was 23 or 22? If you have a mean, then it's likely most of the data is going to be centered around that mean, right? And the thing about means is that if you have a super big value, it's going to throw the mean off course. For example, if you have like a series of numbers like 1, 2, 2, 2, 4, 2, 3, you can say, okay, well, there's a whole lot of 2s, maybe the mean is something somewhere around 2, pretty simple to imagine. But then if you have a sequence of numbers like 1, 1, 1, 2, 2, 3, 5, 2, and then you have 1,000. Even if your first couple numbers are really small, this number over here completely throws the average out of normality, and it gives you a really wacky number that is technically true, but has been heavily influenced by an outlier. So in this case, if the mean was 22 or it was 23, it would have to consolidate somewhere around here, right? Most of the data should be centered around here. And yeah, that is true. Most workers are within the 20 to 30 range, but look at this. Nearly half, like 17 is kind of close to 20, nearly half of the workers are above that. That is a whole lot of outliers that are just dragging the mean towards a higher value. So 23 to 22, it doesn't actually make that much sense. If anything, 32 makes sense because 32, it takes into account, oh yeah, there's a whole lot of workers in this range. I'm sticking around the area, but there is a whole lot of people on the other side that are dragging the mean higher. So therefore, C is the correct answer. And that was a whole lot of data stuff. Does anyone have any questions? All right, doesn't seem we have any questions, so let's continue on. Oh, okay. Population parameters and sampling. Yeah, we're going to continue with the logic questions. So I'm going to give you a couple of definitions first. First of all, what is a population parameter? A numerical value that describes a characteristic of a population. So this can be something like an average value, a percentage that shows how much of a population has a certain trait. It's pretty simple, stuff like, oh, like how many people within a population like cats, or how many people within a population like roses, things like that. And the problem with population parameters is that usually populations are too big to get a proper parameter. For example, if you want to find how many people in the United States like fish, well, you can't interview every single person in the United States. That's really hard, right? So statisticians or mathematicians, what they would do is they'll estimate the parameter by looking at a smaller sample of the population. Keep in mind, the value you get from a sample is almost always never completely correct, but it's usually so close that it's no big deal. Okay, let's talk about population samples. So in order to have a good sample, you need to do a multiple amount of things. So first off, the bigger the sample is, the better, because that means there is a lower chance of having accidental bias. That is a complicated topic to explain that we don't have time for. All you need to know is that bigger, better. Also, sample participants must be chosen at random to prevent biased results. You can use your sample to calculate the parameter of the whole population. An example of this is, say, in your sample of the city population, 20% of participants are Black. If the population of the city is 20,000 people, then you can take the sample you just created and you can apply it to the whole population and estimate that around 4,000 Black people live in the city, because 20% of 20,000 is 4,000. Now, another thing, there's a concept called margin of error, which is the chance that a sample population has a largely incorrect representation of the population's parameters. Basically, margin of error represents the chance that your sample is really, really wrong. That's why we have larger sample sizes and we select participants at random, because having a larger selection scope lowers your margin of error. Now, hopefully we're going to apply this to some actual, yeah, okay. Now let's apply this to some actual questions. Let's take a look at the first one. Okay, we have a quality control researcher at an electronics company, and they're testing the life of a company's batteries. The researcher selects 100 batteries at random. Okay, at random, good, we want it to be random for the best sample. And also, he's selecting only 100 batteries, so he is creating a sample. And he is doing it from the daily output of batteries and finds that the life of the batteries has a mean of 342 pictures with an associated margin of error of 18 pictures. Which of the following is the most appropriate conclusion? So the way margin of error is used here, it says margin of error of 18 people. So it's saying, okay, on average, the battery life is going to be 342 pictures worth, and it's going to fluctuate by an increase of 18 or a decrease of 18. So the plus or minus doesn't mean that it's going to be 342 and it's going to be, it doesn't mean it's going to be 342, 324. I accidentally wrote 324 and then 360. It means that the range or the probable range of battery life is going to be between 324 and 360. Okay. Now, which of the following conclusions is most appropriate? Let's take a look at A. All the batteries produced by the company that day have a life between 324 and 360 pictures. Okay, that seems like a good statement to make, but let's take a look at the other answers. B, all the batteries ever produced by the company have a life between 324 and 360 pictures. Now, what's the difference between A and B? A says all the batteries produced by the company that day, and then B says all the batteries ever produced by the company, so ever produced, the whole lifespan of the company. Now, which one seems more appropriate? Remember in the passage, they said that the researcher selects 100 batteries at random from the daily output of a battery. So he only did it on one day. The trick with these questions is to be as specific as possible, where if they make any sort of generalizations or they go above the scope, that means it's usually not a good answer. Nowhere in the passage did they say that they tested these values on multiple days. They only tested it on one day. Therefore, we're only allowed to talk about that one day. Therefore, A is a better answer than B. And any time an answer is better than another, the worst answer is obviously going to be wrong. But still, we haven't took a look at C and D, so let's do that. Now, C and D are different from A and B in that, one second. The difference is that in A and B, they say all the batteries. And then in C and D, they say it is plausible, the mean life of the batteries. So it is plausible means, okay, we think it's this, but we're not completely sure. And the thing is that when you take a sample, remember what I said about taking a sample, which is that your mean is going to be very close to the actual mean, but it's never going to be exact. So therefore, you can't make super duper sure statements like all the batteries produced or something like that. It's better to use it is plausible because, like I said, you only took a sample. So therefore, you can't be completely sure. So therefore, A is going to be a worse answer. So A and B are out. Now, what is the difference between C and D? C says it is plausible that the mean life of batteries produced by the company that day, okay, that day, and then D says ever produced by the company. We already established that it's wrong to say ever produced in this case. So D is going to be wrong. C is going to be correct. C is going to be correct because it's not too overconfident. It says that we think the mean life is this, and it only talks about the one day. Avnish, you have a question?
Yeah, actually, you have like boxed up from the daily output. Is that the reason why we say like? Is that the reason why we specify that day?
Yes, because it says that they took it at random from the daily output. The daily output means they did it on one day. That's why we are only allowed to talk about one day. Correct. For example, if that sentence changes where they say, okay, they selected at random over the course of a year, then we're allowed to talk about the whole year. The scope is constantly changing. Okay, let's take a look at the next question. Okay. This one is admittedly a little bit hard, so bear with me. A community center offers a Spanish course. This year, all students in the course were offered additional audio lessons they could take at home. Students who took these audio lessons did better in the course than those who didn't take the additional audio lessons. Based on these results, which of the following is the most appropriate conclusion? Okay, they say community center offers a Spanish course, all right? And those who took the audio lessons did better. So A, taking additional audio lessons will cause an improvement for any student who takes any foreign language course. All right, initially you might think, oh yeah, it makes sense, right? Well, hold your horses because they say it will cause an improvement for any student. Now keep in mind, we only saw information from the community center offering the Spanish course, and all the students in the course were offered, only those in the course. Therefore, we're only allowed to talk about people within the Spanish course. We're not allowed to talk about anyone beyond the Spanish course. As much as you would think it makes sense for A, even I think A kind of makes sense. A is not going to be the correct answer because we're not allowed to speak for anyone who is outside of the situation. We're only allowed to do it based on the people within the passage. Oh, wait, I don't know why I circled that. That should be an X. Okay. B, taking additional audio lessons will cause an improvement for any student who takes a Spanish course. Okay, well, B kind of sounds reasonable, right? Because it's only talking about students who take Spanish courses, right? But let's check out the other answers. Taking additional audio lessons is the cause of improvement for the students at the community center who took the Spanish course. Okay, well, it's talking about the Spanish course, it's talking about the community center, and in fact, it's a better answer than B. B is wrong because you notice how they say students at the community center and B doesn't mention the community center at all? So B is too unspecific as well. So C is the better answer. But then we have D, where it says no conclusion about cause and effect can be made regarding students from the community center. And this might be a little bit surprising, but C is wrong, D is correct. Now, why is that? The problem with gathering data is that if you notice a correlation where you gather like this data and then you gather this data and then you said, oh, okay, if this data point goes up, then the other data point goes up, you can identify the correlation. You can say, okay, we notice this pattern, but you're not allowed to say that this causes this. That is a common thing you have to realize, which is this is a very important thing. Correlation does not mean causation. And there are plenty of real world examples of this. One thing I can think of is, oh, okay. Say for example, okay, in England, there is a high amount of knife injuries in England, and also England is a country with a very high amount of air conditioners. Does that mean that there's a correlation between air conditioners and knife injuries? No, it just means that there's a correlation, there's a relationship. Doesn't mean that air conditioners are causing knife injuries to happen, right? So that is why you're not allowed to make conclusions of causation like that, and why D is the correct answer. Okay, that's enough talk. Let's. Oh, okay. I accidentally skipped a little bit. Okay, yeah, here is some practice. I'm gonna give you guys 3 minutes to answer these starting now. All right, everybody, 3 minutes are up, so let's come back and check out these questions. Don't worry, I'm just as eager to get rid of these questions as you are, so let's get on with it. Okay, we have a factory in China that produces rulers, all right? And okay, they're basically asking which of the following conclusions make sense. So we have a machine that enters a factory. It checks every single ruler that was made that day. The keywords are every single ruler and that day. It calculates the average ruler length is 30.5 with an error of margin. Oh, yeah, by the way, there's a small word error there. The and should be between. But yeah, error margin of 0.2 centimeters, which of the following is the most appropriate conclusion? Okay, so A says all of the rulers made in the factory's lifetime. Is that reasonable? Are we allowed to talk about the factory's whole lifetime? No, we only talked about the day, right? So therefore, we can't talk about the whole lifetime. A is going to be wrong. Okay, now what about B? It is plausible that all the rulers made in the factory's lifetime. Uh-oh, red buzzer, lifetime. B is wrong. C, all of the rulers produced that day in the factory have a length of 30.3, and oh, this is another error. That should be between. Apologies if you saw the and you had to change your answer based on that. Okay, C and D, basically the same thing, except D says it is plausible, while C says all of the rulers produced that day. Now, from the last question, you might have thought, oh, okay, well, we don't want to make any assumptions, right? So we should always say it is plausible, right? Because if we say it is plausible, there's no way we can be wrong because we're just making an assumption, right? Well, that is incorrect actually, because we only said it is plausible because we took a sample. In this case, we checked every single ruler. The machine checked every single ruler. That's not a sample, that's just the whole population. So in this case, we are allowed to talk about every single ruler produced that day. Therefore, C is the best answer. D is not necessarily like super wrong, it's just C is better than D. Okay, what about the next question? This is like a general logic question. You have to think about this. We have a magazine and they want to do an evaluation survey, okay? They have a digital poll open from 5 a.m. to 11 p.m. And the first 2,000 people that open it are able to give their opinion. So, what's the biggest flaw with this survey? So, they say they launched a digital poll in Philadelphia. They give us timings and then they give us the amount of people. Okay, A says there are not enough people in the sample size. It should be increased to 3,000. I mean, thinking about it, logically, 2,000 is kind of a big number, but there's a lot of people who live in cities, so we'll just put a bullet in A. A could be the answer, could maybe not be the answer. B, the poll should be open during late night, early morning, instead of opening at 5 a.m. and closing at 11 p.m. Basically, they're saying the poll should have an even bigger time range so that people after 11 p.m. and people before 5 a.m. can answer the poll. Now, I mean, I know there's probably a whole bunch of night owls out there, like, maybe you're on your phone at 2 a.m., watching a show or whatever, but I don't think that people at that time would be answering polls or surveys. And if you think about it logically, there's not going to be as many people awake at extreme times than there are going to be people awake at normal times. So even if you do the tip given in B, it's not going to give you that much benefit. So B is not going to be a great answer. What about C? The poll should be distributed to multiple cities, and not all cities have the same general living conditions. That makes a lot of sense. Not every single city is the same. And they're only talking about Philadelphia. Philadelphia is a very different city from Los Angeles, or it's a pretty decently different city from New York. So you should increase the scope of your sample. So C is going to be the best answer. It's going to be better than A. Okay. So let's continue on. Wait, first, let me see if there are any questions. Doesn't seem like there's any questions, so let's continue on. Glad that wasn't as confusing as last time I did this. Okay, let's move on to some algebra that's a little bit more advanced. Okay, in the equation above, b is a constant. So remember, when they say b is a constant, it means it is not a variable. It means that b has a constant value. It is a number. We just don't know what the number is. Now it says if the equation is true for all values of x, there's a true for all values thing again, the infinite solutions thing. If the equation is true for all values of x, what is the value of b? Now remember, when they say true for all values of x, they basically mean the equations on both sides are essentially the same equation. So we need to make it so that both of the equations on both sides are the exact same equation. So in order to find the value of b is stuck within here. So why don't we expand this equation? Just do the whole FOIL method. It's not that hard. Let's just go at it. So x squared times x is going to be x cubed, then plus 3x squared plus bx squared plus 3bx minus 2x minus 6. Okay. Now here's the thing. This equation up here, I'm gonna erase some of these bits so that we have a little bit more space to work with. Okay, yeah. There are two areas that correspond to the right side. So the x cubed, okay, we have the x cubed there, the minus 6, we have that over here. Now we have our x squared term and our x term. And if you notice, these two terms over here, 3bx and minus 2x, are both single x terms. So they correspond to the 7x. And then these two terms over here, 3x squared plus bx squared, corresponds to the 6x squared. So simply all we have to do is say, okay, what value of b will make it so that if we do 3x squared plus bx squared, we get a value of 6x squared. And obviously the answer is going to be b. I mean, b is the answer is b. That I just noticed that. But yeah, if b is equal to 3, then that becomes 3x squared plus 3x squared. That was an awful plus. Sorry, that's an even more awful plus. Wow. That's going to be 6x squared, so therefore b is equal to 3. Okay, and a couple more concepts to think about is expansion and simplifying. So, okay, there's an important concept I want you guys to remember, which is that if you have a equation of a squared minus b squared, that is equal to a plus b times a minus b, okay? Now, in the above equation, we have 16s to the power 4 minus 4t squared. Which of the following is equivalent to that? So, okay. First off the bat, you have to find the correct pattern. Now remember, we have A, B, B. So the values have to be the same correspondingly. So C is a good answer because we have our supposed A values and our B values. They're the same exact term. Now something like B is going to be incorrect because we have 4s squared over here, but then we have s squared over here. They are two different terms. A, but then we have not A. So B is going to be wrong. A is going to be wrong for the same reason. Now, what about D? Well, D should make sense, right? It looks like it works, but if you expand it, you see that the 8s squared is equal to 64 s to the power of 4, which is way too big. We don't even have to write out the rest of that equation. So D is going to be wrong. C is going to be the correct answer because if you expand this whole equation, it will be equivalent to the above equation. You see how we didn't even actually solve the system. We just looked at patterns and stuff like that in order to find the answer. That can be a real good strategy, eliminating stuff based on patterns. Now, what about the next question? Which expression is equivalent to this? Okay, simple combine like terms. Like terms is when if you have variables or a combination of variables that are the same, then you can add those two terms together. In this case, you have xy squared and 2xy squared. You can add those two terms together since they have the same variable group, and that will turn into 3xy squared. We cannot add the 3xy to any of these because it doesn't have the same variable group. So B is going to be correct. I know it said it advanced, but honestly, kind of simple in some cases. Okay, here is some practice. I'm going to give you 2 minutes to do this starting now. All right, everybody, 3 minutes are up. So let's come back and check out these questions. Or was it 2 minutes? I don't remember. I think it was 2 minutes. Anyway, all right, which of the following is equal to 18x squared minus 12x minus 6? Okay, let's just take a look at some of the general answers. Okay, these all look somewhat plausible, so you just have to expand them out naturally yourself. Oh, you can immediately eliminate b because you have 6x and 3x squared. Even if you multiply those two together, you get 18x cubed, which is a whole level of order higher than 18x squared. So b cannot even be possible. Same thing for d, actually. You get 18x squared times x. It's going to end up with 18x cubed as the first term, which is impossible in this situation. We can't do that. So D is going to be wrong too. Now A and C, okay, there's no way around it. You just got to expand it. So what does A look like? 6 times 3x squared minus 3x plus x minus 1. And okay, this minus 3x plus x converts into minus 2x. If we expand the 6 out, we get 18x squared minus 12x minus 6. Oh, wow, look at that. It's exactly the answer. Therefore, A is the correct answer. You don't even have to look at C if you get the exact answer. Okay, now it says the expression up here is equivalent to 3x cubed plus 7x squared minus 4. What is the value of A? All right, no way around it. You got to expand the top equation. So, okay, ax cubed plus 2ax squared plus x squared plus 2x minus 2x minus 4. Okay, well, the 2x minus 2x cancels out, so that's why there's no x term. And then, okay, we have 2ax squared plus x squared. So, we can factor that out, actually, where it becomes, oh, actually, now I realize we don't even have to factor that out. They're asking us for the value of a, right? And the x cubed term corresponds to the 3x cubed. Therefore, the a has to correspond to the 3. So a equals 3. And therefore, the answer is B. If you wanted to be completely sure, if you incorporate a into the x squared term, it will also end up as 7x squared, further confirming the answer. Are there any questions? All right, doesn't seem like there's any questions, so let's move on. Oh, okay, then I completely forgot. There's a mini quiz here too. Yeah. So this one looks a little bit. I'll give you guys 3 minutes to do this. We're not slow pokes, right? You can do it fast. All right, yeah, 3 minutes starting now. All right, everybody. So 3 minutes are up. Let's come back and check out these questions. So first we got a data table, all right? They ask how many non-red frogs live in the forest and wetland. So what I like to do with these questions is when they ask for specific conditions, I like to highlight those conditions, or in this case, like eliminate the conditions because they ask how many non-red frogs. So non-red means no red. Let's cross this bar out. Okay. And then how many non-red frogs live in the forest and wetland? So these are the non-red frogs. This is the forest and wetland. They're talking about this section. This section right over here. All I have to do is add those values up and we'll get our answer. So that is going to be 350. Therefore, A is the correct answer. Okay, 2, whole bunch of percentages. I like to mix questions up like that. Okay, a whole bunch of stuff happens. How many frogs are left in the desert? So, okay, what happened? A calamity wipes out. Let me clear first so I can get space. Okay, 50% of the red frogs in the desert are wiped out. Okay, so 50% of 70, they're going to be cut down to 35. Okay, 90% of the blue frogs in the wetlands. Okay, 90% of them are killed. So it's going to be 9 blue frogs left in the wetlands, and 40% of the green frogs in the desert are killed. So 40% of 200 is going to be 80, and minus 80 is going to be 120 green frogs left in the desert. How many frogs are left in the desert? Be careful if you put A, that's going to be wrong because remembered, I said 90% of blue frogs in the wet. That was an awful underline. I said 90% of blue frogs in the wetlands. I wasn't talking about the desert. I was only talking about the wetlands. So if we add these values up, 35, 10, that's 45, 45 plus 120, 165, you'll see B is the correct answer. Okay, next, which of the following is equivalent to the above equation? Okay, yep, that shouldn't be too hard. One thing you can do is you can factor that equation out. You see, oh, there's a common factor of 3. Why don't we factor that out? 3, 4x squared plus 4x plus 1. And okay, we see this equation over here. Isn't this sort of similar to B? But B is different because it has 4 over 3, whereas this equation that we just factored has a 1. So it can't be correct. B cannot be correct. Now, what about A? A, if we do 6x squared, that's going to be 36x squared, just on the first term. That's way too large. So A is going to be wrong. What about D? Well, D, it does give us 12x squared plus 12x, but then the 4 over here, 12 times 4 is going to be 48. So D is going to be wrong. C is going to be correct because, if you factor out, it equals that. Also, there is a little trick where another concept that is helpful is that if you have A plus B squared, it's equal to A squared plus 2AB plus B squared. I'm pretty sure your algebra teachers drilled that into your head, and you'll see that C actually corresponds to that equation. So, you can easily recognize things like that, and you can come to an answer even faster. Okay. Okay, we have a new expression here, and it's equivalent to that expression right over there. Find the values of A and B. Okay, so let's expand the first equation first. So it's going to be what? 3b x squared minus 12. Oh, wait, no, not x squared. It's going to be x cubed. My bad. X cubed plus, hey, wait a minute. We have 3bx cubed, right? And we know that it's 3bx cubed is the only cubed term in the equation. So that corresponds directly to 15x cubed. Therefore, B has to be equal to 5, right? Only one answer has 5. Therefore, the answer is D. We don't even have to do any more work. If you notice something where all the answers are very distinctly different and you only need to find one part of the answer, you can find the answer a little bit quicker than you thought. Okay, now next question, one of those population parameter questions. We have a violin company. Okay, keywords, since they first started producing, okay, every day, machine checks the length of 20% of the strings. Checks the length of 20% of the strings. And then it calculates 32.5 average with a 0.5 centimeter margin of error. All right, which of the following statements is true? Now, what about A? It is plausible. Okay, first let's differentiate between A and B and C and D. The difference is that one is saying it is plausible, the other one is saying all of the strings. Now, the thing is, we're doing a sample, right? Because we're only doing 20% of the strings made each day, so we're not allowed to talk about all the strings. We are only allowed to talk about the sample, and we can only say that it's plausible. Therefore, C and D are wrong. Now, what about A and B? What's the difference between A and B? A says it is plausible that all the strings made on one day have the length, and then B says it is plausible that all the strings made in the company's lifetime. Now you might think, oh, A is the better answer because it is less generalized, right? Well, no, that's wrong actually, because remember they said since they first started producing, where's the highlighter? Yeah, since they first started producing. So they have been checking throughout their whole company lifetime this sample. So in this case, we are allowed to talk about the entire lifetime, which makes B the best answer. All right, are there any questions? Doesn't seem like it, so let's move on. Okay, the quadratic equation. This is one of my favorite parts and not so favorite parts at the same time. Okay, so the quadratic equation, okay, if you haven't learned what the quadratic equation is, I'm just gonna say you're just gonna have to memorize it for the ACT. If I remember correctly, the ACT does not provide an answer sheet. They do not provide they do not provide a formula sheet for you. They didn't give me a formula sheet, at least when I took it. So you guys are probably not gonna have one either unless they change the regulations. So yeah, you're gonna need to memorize the quadratic formula. If you're like a ninth grader or like anything younger than that and you haven't learned the quadratic equation yet, don't worry, you'll learn it in school. But yeah, the quadratic equation works where if you have a quadratic equation of ax squared plus bx plus c, where a, b, c are coefficients, then you take those values of a, b, and c, and you plug them in to this equation over here that will give you x values that will be solutions to the equation. So let's put that into action here just to have a trial run. Okay, first of all, let's move this x to the other side. So let's do x squared minus x minus 3 is equal to 0. So in this case, the first and second terms don't have coefficients, so those are going to be imagined as 1. And then if we use a quadratic equation, x is equal to negative. Okay, what is b? B is going to be -1. So -1. Okay, you know what? Let me do this on the black portion of the screen so it's easier for you guys to see. Okay, yeah. X is equal to -1 plus or minus -1 squared minus 4. What is A? A is equal to 1. And then C is equal to -3 over 2A over 2 times 1. And this is equal to 1 plus or minus. Okay, we know this is a positive 1. Therefore, we can eliminate A and B since they're negative ones. Plus or minus 1 plus 12. Remember, this is a negative over there. Let me use the highlight feature. Okay, yeah. There's a negative over here, but then we have a -3 over here. So that overall cancels out into a positive. And then we just have 2 on the bottom. So this turns into 13. 1 plus or minus square root of 13 over 2. D is going to be the correct answer. Are there any questions? Nope. Okay, let's move on. Okay, yeah. Here is some practice for using the quadratic equations. All right, I'm gonna give you like 10 seconds to get some paper or something so that you can do this. All right, 10, 9, 8, 7, 6, 5, 4, 3, 2, 1. I know that was faster than 10 seconds, but we're running out of time, guys. So I'm gonna give you guys 3 minutes to do these 4 questions starting now. All right, then, everybody, 3 minutes are up. So let's come back and check out these questions. Okay, I'm just gonna go over 2 of them because since we don't have that much time, I'm gonna go over the first one. So we gotta move all the terms to one side. So this is gonna be -20. So we're gonna have x is equal to 3 plus or minus 9 minus 4 times 2 times -20 over 4, and that's going to be equal to 3 plus or minus the square root of, what is all that add up to? 9 plus 160, and then 9 plus 160 is equal to 169 over 4. And if you didn't know, the square root of 169 is actually a perfect square root that is equal to 13. And then you can actually find solid numerical answers from this. You'll be able to get 4, and you'll be able to get negative 2.5. Now, actually, since we don't have that much time and it's a pretty redundant topic anyway, not much to learn. We're just gonna move on. Okay, quadratics and logic, a little bit more fun. Okay. If x is greater than 0, this is an important condition. If they give you a condition like this, keep it in mind. If x is greater than 0 and 2x squared plus 3x minus 2 is equal to 0, what is the value of x? Okay, what is the value of x? Use a quadratic quadratic formula, right? -3 plus or minus 9 minus 4ac. Okay, that's going to be plus 16 in this case. Over 2a is going to be 4. All right, -3 plus or minus 5 over 4. The 2 answers we get will be -2 and will be 1/2. Now you might think, oh, A is the correct answer, right? No, remember, x has to be greater than 0. It's -2, it's less than 0. So we can't use -2, we can only use 1/2. Therefore, I'm covering it by accident. Okay, therefore, B is the correct answer. Okay, now what about the next one? What is the sum of the solutions of these 2 equations? Okay, if you wanted to do it the normal way, you would simply expand both sides of the equations. However, excuse me, another way to do it is to square root both sides. Square root, and that was an awful square root. Square root, square root. Now, there's an issue that comes with this, and I'll explain it now. Okay, you know how when you square root something, like take square root of 4, you say, oh, it's equal to 2, right? Well, the thing you might forget to do is it's actually equal to plus or minus 2. Because think about it. If you do 2 squared, that's equal to 4, right? And then if you do negative 2 squared, that's also equal to 4, right? So when you're doing square roots, you have to do it reversibly, where you're thinking, oh, okay, it's both positive and negative, because if you did negative squared, that would be positive. So it's only fair you think about the negative side. Similar thing over here as well, where if you have a squared is equal to b squared, you have to separate it into two situations where a is equal to negative b and then a is equal to positive b. So, okay, I'm gonna write that on the side. And in this case, we have to follow the same rule. So, whoops, sorry, accidentally knocked a cabinet. Okay, so if we square root those, we end up with 2x minus 1 is equal to, let's consider this our a, let's consider this our b. First scenario, let's go with the positive route, where we go with positive b. So positive b is just going to be normal x plus 2. And then we can simply solve it. So x is equal to 3. Okay, now we have to do the negative part, where it's, okay, 2x minus 1 is equal to negative x plus 2. 2x minus 1 is equal to negative x minus 2. And now we have to simplify this. Okay, so we get 3x is equal to negative 1, x is equal to negative 1/3. And they say, what is the sum of the solution? So we got to do 3 plus negative 1/3. That is going to equal 8/3. And therefore, A is going to be the correct answer. So yeah, in this case, we used square roots, and it worked out. Avanish, you have a question?
Yeah, actually, what I've did is like I've like actually like added like I squared all of them like to I expanded all of them and I just add them all up. And when I got
Yeah,
the
yeah,
quadratic
that
equation, no, when I got the quadratic equation, I applied them negative b divided by a formula, which gives us the sum. Would you
yeah,
suggest that?
yeah, that also perfectly works as well. Personally, for me, that might take a little bit longer than the method I did, but that's because I'm more comfortable with using square roots when I see fit. If you think that the method that you suggested is more comfortable for you and you'll be able to do it faster, remember speed is key on the ACT, then by all means you can do it. Remember what I said, where as long as you get the final answer in a good time, then it's okay to do.
Okay,
No problem.
thank you.
No worries. Pardu, you have a question?
Yeah, so would it be too long if we use the quadratic formula for both sides? Uh,
Yeah, it would probably be really long if you use the quadratic formula for both sides. You can do what Avanish said, where he expanded both of the equations, and then he combined them into one quadratic equation, and then he did the quadratic formula for that one equation.
okay, thank you.
No problem. Okay. Oh boy. Okay. Creating quadratics. This is one heck of a logic puzzle. Do we have time? Okay, 5 minutes. I think I can do this. I believe in myself. Okay, brace yourself. This one's gonna mess your brain up. We have a car traveling at X feet per second. The driver sees a red light ahead, and after 1.5 seconds, the driver applies, 1 second. Okay, the driver applies the brake. After the brake is applied, the car takes x over 24 seconds to stop, during which the average speed of the car is x over 2 feet per second. If the car travels 165 feet from the time the driver saw the red light, which of the following equations can be used to find the value of x? Okay, what is x again? X is equal to the speed. Now, they're saying that the car traveled a certain amount of distance when it stopped, right? So if we relate the distance they traveled to the amount of time it took for them to stop, we can make an equation that represents x. So two parts to this. So there's two segments where there's the portion where they, all right, let me get my typer out. All right, there's two portions. One where they don't apply the brake, and then there's going to be another one where they apply the brake. In the first portion where they don't apply the brake, the car is traveling at x feet per second, and 1.5 seconds pass. So the total amount of distance they travel is 1.5x, where x represents feet per second, right? And then this one represents 1.5 seconds. So unit wise, they cancel out. If you want to see what I mean, 1.5 seconds times x feet per second. The seconds cancel out and we're left with feet. So we're trying to get the amount of distance that they traveled, right? Now, okay, after they apply the brake, the car takes this amount of time to stop, and the average speed of the car is x over 2. And distance is simply time multiplied by speed, right? Or by velocity again. So it's going to be equal to x over 24 times x over 2. Remember, this is time, this is speed. Same way that this x is also speed, and that the 1.5 is also time. So we end up with x squared over 48 plus 1.5x. So this over here is equal to total distance. And what is the total distance they say that the car traveled? 165 feet. It's equal to 165. Now, if you notice, this kind of looks like a quadratic equation. If you move the 165 to the other side, you get x squared over 48. Wow, I'm out of breath. Plus 1.5x minus 165, which is equal to 0. Now they say, which of the following equations can be used to find the value of x? Well, if you notice, all the x values, all the x squared values have no coefficient. They have no 48 fraction. So we got to multiply the whole thing by 48. And if you multiply the whole thing by 48, well, you end up with x squared plus 72x minus, okay, what is negative 165 times 48? Yeah, okay, this is going to be negative 7,920, which is equal to 0. Therefore, D is going to be the correct answer. Yeah, that was a whole lot we had to do. I'm definitely expecting a question. Once again, Avanish, what's your question?
Wait, can you repeat how did you get x squared divided by 48?
Oh, x squared divided by 48?
Yes.
Yeah, so there was a scenario. There's two parts, right? The part where he applies the brake, and then the part where he doesn't apply the brake, and the part where he applies the brake. For the part where he applies the brake, they tell us that it takes x over 24 seconds to stop, and during this time, the average speed is x over 2. And the amount of distance one travels is equal to time
Mhm.
multiplied by speed. So in order to find the distance, we simply did x over 24, which is the time, and then we did x over 2, which is the speed. We multiplied those two together, and then we got x squared over 48, which represents the amount of distance the car traveled after they applied the brake. Does that kind of make sense?
Yes, it does. Like, so the time multiplied by speed gives us distance. So what about for
Yes.
one and the 1.5 seconds reaction time? Like, can you just like
Oh,
one briefly, like if that's possible?
can you what? Sorry?
No, can you explain 1.5x again, if that's
Oh,
possible?
yeah. Yeah, sure, no problem. Okay, well, we are a little bit running out of time. For now, if anyone would like to leave, you are free to leave. I'll continue explaining this. But yeah, the 1.5. Okay, we just talked about the scenario where they applied the brake, right? Now, what about the scenario where they don't apply the brake? They say that the car is traveling at x feet per second, and that time is equal to 1.5 seconds. So the time, you simply do 1.5 times x, and that is how we got 1.5x. Simple as that. Yes, Avanish?
Yeah, but how can you come up with a scenario? Don't apply the brake and apply the brake. Like, is it like something we would need to know?
Uh, yeah, it's just like a logic you have to do where they're asking for, okay, well, we need to find out how much distance the car traveled, and the speed and distance are changing twice. So we just created two separate terms for that. Honestly, this is really, really complicated. I don't blame you for being confused by this. Rest assured, on the ACT, it's not going to be as complicated as this. I purposely chose a super complicated question in order to try to prepare you guys. But you should be able to know how to construct a quadratic equation, but over time it will come with practice, so you don't have to worry about it too much.
Wait, like by any chance, the 1.5x is the distance traveled like before the brakes is applied.
Oh yes, exactly. That's the distance before the brake is applied.
Oh, so the 1.5x is like before the distance traveled before the brakes is applied, and then the x by 24 and multiplied by x by 2 is the distance traveled after the brakes is applied,
Yes.
right? And then
Yep,
165.
exactly.
Obviously.
Yep.
Okay, yeah.
You got
Thank
it.
you.
You got it. No problem. Oh yeah, okay. So yeah, this will be the end of today's seminar. I see some people asking me if they can leave. I just want to clarify, I'm not your guys' like dad or parent. If you have like a personal emergency, you guys can leave whenever you have to. Obviously, it would be nice if you stayed, but yeah, I can't control that. So yeah, just putting that out there. But yeah, once again, thanks for coming to today's session. It was great to have you all here. If you have any questions, you can ask me. I'll stick around for just a couple minutes, and yeah, that'll be it. See you guys.